Right? So what we're going to talk about today. So this week and next week, we'll be talking about um, market structure, um, how companies compete in the market. Now, as an intro course, we cover a lot of topics. So each topic, we don't actually spend too much time going in depth. So we're going to talk about two extreme cases. One is the case where you have a lot of competition, which is this case, which is this model, the perfectly competitive market. And then we're going to talk about the case with only one seller without competition, monopoly. Now, in reality, you would have a lot of different degrees of competition in between. In many markets, you might have 2 sellers, 3 sellers, 5 sellers. So there will be various degrees of competition. In this course, we will only cover the two extreme ends. If you're interested in studies that look into what happens in the middle ground, then you can take a course in industrial organization. Even though we're going to talk about the two extreme cases, it turns out that you can actually observe quite a bit from there, especially when it comes to monopoly. So how is market price determined? So we have assumed that so far we have assumed that buyers and sellers take market price as given, but it doesn't really say what condition would make that true. You need buyers and sellers to take market price as given to get the first fundamental theorem of Weber economics. The first fundamental theorem says that, well, the market equilibrium is efficient because if you are willing to pay a price above the cost of production, you will be able to buy it from the free market. This is only true if the selling price is very close to the cost of production. So the seller is not making a lot of money. If the seller is trying to make a lot of money, then even if you're willing to pay above the cost of production, you might still not be able to buy the product because the seller is pricing very high, right? So it might cost something $10 to produce, but the seller might sell it at 100. So the fact that you're willing to pay $50 for a product does not mean that you can buy it, because the seller might want to sell it for a very high price. So we have assumed that buyers and sellers take the market price as given. They don't really try to set a higher price. Okay, so how do we actually ensure that what condition ensures that sellers and buyers do not try to set a price that is very far away from the benefit and cost of the product? So you need competition, essentially. So we're going to talk about two cases. One case is, as I said, we're going to talk about two extreme cases. One is what happens when you have a lot of competition, and the other case is what if you have no competition? And we're going to look at a case with a lot of competition. And where do you find cases with a lot of competition? If you look around you, it kind of depends on how you see how you view competition. For example, is a Chinese restaurant competing with a Western restaurant? So now it's not very clear, right? There are some people who only like to eat Western food and some people who only like to eat Chinese food. So they are not really competing directly, right? So if you look at, but then they do compete, because if you're just thinking about food, then Western food and Chinese food are both food. So if you're just looking for food, you might consider both. So competition, whether it exists and the degree to which it exists, depends a lot on how you see the different sellers. We're gonna think about a case where we don't need to worry about that. So we're gonna try to find examples where the sellers are selling products that are very similar. And where to find that? There's no better place than going on Taobao. So So this is the Taobao page for pencils. It's pretty amazing. Like Taobao is, you can actually buy pencils. And so this is for the Zhonghua brand pencil, right? Zhonghua Pai. You can see I think this is actually a very good example of competition. So if you look for this particular brand of pencils, you would get many listings, many sellers selling the same type of pencils. Now I have captured the screen with only 8 sellers, but there are a lot more than just 8 sellers. So you have a lot of sellers. You take a look. The first seller is selling for 24 cents, second seller 25 cents, third seller 25 cents, fourth seller 25 cents, and so on. The prices are actually quite close, which is not surprising. If you go Taobao is like, I think at least I asked Taobao to arrange the outcomes by price, so it's not surprising that you can't be pricing a lot higher than the competitors, because otherwise who would actually buy from you? So it's a very interesting case. You have all these sellers selling similar products. What happens in this market? Another thing that's very interesting, I think, about Taobao is the username of the sellers. If you look at the username of the sellers, what do you see? You take a look at the username. It looks like this doesn't actually work. Does it have battery? Never mind. Take a look at the usernames. Right. The first one is actually the cheapest one. Is actually quite normal, right? Guardian, right? Which is common, right? The second one. 行行思思1015 2025. Okay, that's kind of. Then third one, Wang Dalei 2012. And then the fifth one, 金丝年华永不败. It's just like, okay, I guess there's so many sellers that it's very hard to come up with a name, right? I'm actually tempted to just buy it based on the names, because otherwise it's pretty much identical, right? It's the same pencil, it's almost the same price. How do you differentiate? You don't. In fact, in this case, you're not differentiating. So, okay, so what conditions are necessary to consider a market competitive? If you think about the market just now, there are many sellers. So if a seller raises price, he should lose a lot of business. You can imagine, with all those sellers selling like 24 cents and 25 cents, I'm basically not going to consider anyone selling like 26 or 27 cents. I don't need to. I have many sellers who are selling at lower price. They're selling similar products. They are all selling the same brand of pencils. Many potential sellers and buyers. So we'll see why I highlight potential. In the previous example, you do have a lot of sellers and buyers, not just potential. You actually, in fact, have a lot of buyers, sellers, and buyers. And the perfect competition model imposes these conditions to the extreme case. So we assume that the sellers and buyers do not actually set different prices. They just take the market prices given. So you can imagine that they just go online, take a look at the price that others are selling, and charge the same price. This assumption is probably not true in most cases, because if you look at just even Taobao, there are some differences in the price they set, right? You have some 24 cents, some 25 cents, 26 cents. They're close, but not identical. So this is certainly a strict assumption that is probably not going to be true. It might make more sense in the stock market, where you often just buy and sell at the market price. So maybe in that case, but not so much in any other case. Sellers sell identical products. Once again, this is an assumption, and it's not as easy to satisfy as it might seem. So we're talking about identical products. If you take the example we have just seen, the different sellers are selling the same brand of pencils. Assuming that they're not lying, right? They're not selling counterfeit pencils. I'm not sure whether you can have counterfeit pencils, but in China you can have counterfeit rice. So I guess you could have counterfeit pencils. And assuming that they are actually all actually all selling the genuine pencil, then they are selling identical products. However, when you're buying from a seller, you're not just buying the physical product. There are other considerations, right? When you anyone really like Taobao? Anyone actually spend a lot of time Taobao? No, really? No. Like my sister brought like her clothes on Taobao, and she bought like clothes, shoes, anything she could buy on Taobao. You can buy shoes on Taobao for like $19. They last for 2 weeks. Then it just like breaks into half. Then what do? Buy another one. Or you can buy clothes, right? Clothes. The way now, I always find it very interesting buying clothes online, right? Because you can't try. How are you supposed to buy clothes online? Well, it's not going to be a problem because it's so cheap on Taobao, you can buy 3. And just pick the ones that you need and throw away the other 2. It's completely wasteful, but that's something you could do. So on Taobao, it's pretty easy to find sellers that sell identical products. Pretty much anything you search, you will have a list of sellers coming up. How do you pick? What do you think? People don't actually necessarily go for the cheapest one, right? So one of the useful feature of Taobao is you have ratings, right? Besides looking for the cheapest price, you might also look at the ratings, and you want to buy from a reputable seller, right? And so that's one consideration. So even if the different sellers are selling identical products, like they're selling the same selling the same pencils, they're selling the same identical product, they're selling the same physical product. They're still not completely selling the same product because some sellers might be more reputable. Perhaps they have better customer service. When you pay, you're also buying the customer service. Another consideration is on a site like Taobao, the sellers do not necessarily come from the same place. You might have a preference to order from a place that is close to you because that means the product will reach you faster. Once again, in that case, even if the sellers are all selling identical physical products, the fact that they are not of the same distance from you might mean that they're not selling the same product. A seller in Shenzhen might be selling a pencil that can be shipped to you in 1 day. A seller in Xinjiang is not going to be able to ship to you in 1 day, but that will be a different product. So even with the same physical product, you might not have the same service. And service is something that you do pay money for. So once again, it's not actually that easy to get identical products, but it's an assumption that we're going to make. Fine. Next this is obviously not going to be realistic. We're going to assume there are infinitely many potential sellers with free entry and exit from the market. So many sellers, they can come and go as they wish. This is not realistic because first, obviously, you don't have infinite number of sellers in reality. And second, if you want to set up a business, it takes time and money. In many places, you need a business license. You need to set up your operations. Maybe you need a place to work. All these takes time and money. So in reality, it's not that easy to just say there will be free entry because that doesn't really happen in many businesses. But we're going to make that assumption because it makes things simpler. In particular, if you don't assume infinitely many potential sellers, that means you would have to consider, all right, how many potential sellers there are. What if there's so much demand that there aren't enough sellers producing the product? we don't really want to consider those situations, so we're just going to assume, okay, there are many sellers. There's always enough people to fulfill the demand from the market. Now, for simplicity, we're going to assume that they have identical cost functions. This is just to make the math easier. Without this assumption, we usually still fine. And you can imagine, this is like Taobao. This is a situation with many small sellers. And they are facing a really big market. So that's why Taobao is a good example. When a seller, maybe a seller could be from a very remote province, but he can sell to the whole country, including Hong Kong. And so that's a very big market and a very small seller. How do you get price ticking? Now we're gonna have a demand curve that is actually a horizontal line. And what does it mean? So the reason why the demand is going to be horizontal in this particular model is we're going to assume that if you raise your price, no one will buy from you, right? If you raise your price above the current market price, no one buys from you. So because no one buys from you, right? Then that means that any price above the market price, there's exactly zero demand, no demand. So you can imagine it looks like this, right? There's exactly no demand at any price above the market price. And, what do I do? So the problem is, here you go. So this Surface tablet actually is malfunctioning. Part of the screen is not responsive. So sometimes when I click on it, it doesn't respond. Next, so we assume that if you raise your price, no one buys from you. And then we also assume if you lower your price by any amount, there will be many people buying from you. How much? More than you can handle. So we just assume that it's going to be infinite. Once again, this is obviously an assumption. There is no such thing as infinite demand in the world. But to make sure that it's always bigger than how much a seller can handle, we just assume it's infinite, right? So if a seller lowers its price, it would have more demand than it can ever take. One way to look at this, so if you make these assumptions, the demand curve faced by each seller is horizontal. It's horizontal because if it tries to charge a higher price, no one buys from the seller. If it tries to charge a lower price, then it has so much demand that it cannot handle. So the seller will always stick with the market price because that's all it needs. It can sell as much as it needs at the market price. So that gives you price ticking. That is, all right, I won't raise my price because if I raise my price, I have no customers. I won't try to lower my price because I don't need to. There's no need for me to lower my price to attract more customers. I have as many customers as I can handle right at the market price. So price ticking means a horizontal demand. You can view a horizontal demand as a tiny fraction of a very big downward sloping demand, right? Imagine you have a downward sloping demand. And because the seller is very small, the seller is only a tiny part of the whole market. So if you magnify the tiny part of the whole market, then you would have a very flat line, right? This is part of the demand. So that's why you can imagine this is the case. The reason why demand is flat because you're looking at a very tiny part of a downward sloping demand, and when you do that, then the line becomes very flat when you zoom in. This model has two components. It has a short run part and a long run part. Short run, it says that you're supposed to use the short run cost function, and the number of sellers is fixed, so there's no entry or exit. If there are 5 sellers in the market, there are just going to be 5 sellers. And you solve the model by calculating the market supply, which is just the number of sellers times the individual supply, and equate demand equals supply. Basically, this is what we have always been doing. Demand equals supply. You can see what we have been doing in the past as the short run. Demand equals supply. So there's really nothing new in this particular case. You just find out what demand is, find out what the market supply is, equate the two. This is the short run equilibrium. So that's all it is. So we're going to have an example now. So demand for ice cream cone is given by Q equals to 126 minus P. The short run average cost is AC equals to 20 over Q plus 6 plus 5Q, and the short run marginal cost curve is MC equals 6 plus 10Q. There are 5 sellers in the market at the moment. Assume the sellers cannot shut down. Find the short run market equilibrium price and quantity. All right, so all you need to do is the same as before, but in this case, you are given the marginal cost and not the supply curve. So you need to first find the individuals. You need to find the individual supply, and then you find the market supply, and then you find the equilibrium. So let's first start with the market individual supply. You are given marginal cost equals to 6 plus 10Q, and 2 weeks ago, when we talk about production, we argued that marginal cost equals supply curve. A marginal cost is the supply curve. If there's a lot of competition, sellers cannot charge a high price. Their price would reflect the cost of production, which is marginal cost. So we can get the supply curve from marginal cost curve by rearranging the marginal cost curve. You first replace marginal cost with P. So we're assuming that under competition, sellers set the price equals to marginal cost. So this is the reason. They set the price equals to marginal cost. Then you rearrange to put Q on one side and P on the other side. So now you have P minus 6 over 10 in the rearranging. So this is the individual supply. So you just replace MC with P, then you rearrange to get Q as a function of P. Market supply is the number of sellers multiplied by individual supply. So this is going to be 5QS, which would be P minus 6 over 2. So that's the market supply. Finally, you have the equilibrium. The equilibrium is QD equals QS. Which would be QD equals QS. (106 minus P) equals to P minus 6 over 10. So that's you can rearrange. So that's 1,260 minus 10P equals to P minus 6. So you have 1, 2, 4 equals to 11P, right? Okay, here's the part where you can break out the calculator. 1,254 divided by 10, 11, 114. Okay. And then you solve for the quantity too. So the market price is going to be $114 if I calculate correctly, right? So P minus 6 over 10 is the individual supply. Then P minus 6 over 2. Oh, it's wrong. Sorry. This is 2. This is market supply. Okay, so wrong number. So this is times 2. So it's actually 252 plus 6. 252 plus 6, those are 258 equals to 11p. Oh, not 11p, 3p only. 3p. So that's p equals to 86. Is it? Yeah, I think it's 86. 8, 3 is 24, yeah. Okay, so price is 26. You find the quantity, the big quantity. So the quantity sold is going to be 126 minus 86, which is 40. So 40 units will be sold on the market, and individual supply would be 40 divided by 5 equals to 8. So each seller is producing 8 units. So that's the way you solve the short run, which is just the same as what we have been doing. In the short run, the seller's supply curve is the marginal cost curve because they are setting the price according to cost. Aggregate the individual supply, set demand equals supply. That gives you the equilibrium, right? The sellers, there is some competition in this market. However, the sellers do make money. Now, if you calculate how much money they make, they each producing 8 units, right? They're each producing 8 units. So profit per seller. The profit per seller is they are charging $86 each. Subtract the average cost. Subtract the average cost of producing 5 units, or 8 units, sorry. They're each producing 8 units. And then multiply by producing 8 units, you get the profit. So that's 86 minus 20 divided by 8. So that's 2.5 plus 6 plus 58 is 40. And that multiplied by 8. So that would be something like, I think around 200. 86 minus 2.5 minus 6 minus 40 times 8, something of 300. All right, so they're making $300 of profit each. But aren't they competing? Aren't they competing? Why should they be making money? Now let's think about how the competition works in this market. So they're making money, even though they're under competition. Now in the short run, the number of seller is fixed. The number of seller is fixed. The sellers do compete to offer the lowest price, but when you compete to offer the lowest price, you only do so if you can make money. You can at least break even. When you can at least break even by selling. There's no point in undercutting your opponent only to lose money. So they compete on price, but only to the point where they're going to break even. Right? So they're not going to sell at a loss. What does that mean? So let's say there's a customer. There's a customer, and she wants to buy the product from one seller. The seller looks at their cost of producing that product and say, well, okay, if I produce this product for you, it would cost me $100. So I'm going to sell it to you at $100. And if there is a seller with a cost of 90, then the seller can say, well, I can sell it to you at $90 because I have a low cost. but no one is going to sell at a at a price lower than cost. If a seller has a cost of 100, he would want to sell at 100. He would not want to sell at a $50. So competition is still limited by the cost of producing that particular unit. We have assumed that all sellers have identical costs. So they will all be facing a similar situation. Imagine a customer comes in. And this is where the seller's at right now. The seller simply cannot charge lower than marginal cost, because that would lose their money. That would actually lose money for that unit. If you come in at this point and say, I want to buy this unit, the price as given by marginal cost is the lowest the seller can charge. Otherwise, they're going to lose money on that unit. The reason why they make money, is because they are charging the marginal cost for the very last unit they are selling right now, but they can be making money because previous units actually cost less than the last unit. The previous units have lower cost. So in the short run, a seller can make profit even under competition if they have lower costs initially. If they don't have lower costs initially, then they don't make profit. So they compete to offer lowest cost for the last unit. They're only competing to offer the lowest cost for the last unit, and these units are profitable. Oh, maybe I should highlight this range. The previous units they are actually profitable because the cost is lower. The very last unit is not profitable. The very last unit is only break even. Under competition, what would you see? Now, under competition, you would see something like, so McDonald's. This is from a few years ago because I can't find an updated version that works well. So McDonald's sells their discount menu, the discount meals for now is like $24, but a few years ago it's $21. And at the same time, Yoshinoya was also selling their meals at $21. Now, it certainly was no coincidence that the two sellers decide to set their price at $21 at the same period of time. This is competition. They are competing for the same customers, and the customers are very price sensitive. To attract those customers, they have to compete on price. And under competition, they end up charging the same price for their products. How would this play out in the long run? Let's think about what happens in the long run. In the long run, the new sellers can enter. So let's say we're right here, right now. Right now, the sellers do make money on the units they produce, on the units they produce, except the very last one. So they're making money. Price is higher than average total cost. They're making money. What can I do as a new seller? So I look at this situation and realize that, well, I can undercut everyone else by charging a lower price. I won't be producing as many because I'm charging a lower price, so the break-even point is actually lower. So I'm going to undercut everyone else. I'm going to charge a lower price, and I will make some money. Okay, if one person can come up with this idea, there's nothing that stops someone else to come up with that idea again. Another seller can come in and say, well, I can charge even lower and undercut the previous seller. I would still be making a profit, so it's worthwhile to do that. You can imagine that this process would not stop until there is no profit to be made. As long as there's profit to be made, someone will have come up with this idea that I can enter the market and undercut everyone else. Because we assume there are infinitely many potential sellers, this process can go on forever, as long as there's money to be made. This is why the assumption is important. If you assume if you don't assume there is a lot of potential competitors, at some point there's no one to enter the market, so profit stays positive. With many sellers, new sellers keep entering until there is no profit. When there's no profit, no one wants to enter the market. You don't make money anyway, so this process stops. So what happens in the long run is when you allow free entry, new sellers would keep entering to undercut existing sellers, and this process only stops when price equals to the lowest average cost. You can't charge lower than the you can't charge lower than the lowest average cost, because if you do, you are certainly going to lose money. So no one wants to charge lower than the average total cost. So long run, solving the long run model is the same as saying you want to find the long run price and the long run quantity. How do you find that point? This diagram already shows you how to do that. Simply put, you are looking for the intersection between marginal cost and average total cost. You're looking for that region because as we mentioned before, the intersection between marginal cost and average total cost is the efficient scale. The point at which average cost is the lowest. So this is what you want to find. So long run has two implications. One, you should use long run cost functions. No one really cares about that. Much more importantly, number of sellers is variable, so free entry and exit. So we have already mentioned all that. And as I said, because sellers compete to the lowest cost. The lowest cost is the efficient scale. You find that by finding the intersection of marginal cost and average total cost. So you have to find that. There are some cases, not in this course though, there are some cases where you cannot find the efficient scale. Because there's nothing that says that the average cost has to be U-shaped. In more advanced costs, you could have average cost that is average total cost that is upward sloping, average total cost that is downward sloping. In that case, you can't find the intersection. There is going to be there might not be an intersection. So those are cases that you would have to consider in a more advanced course. In this course, we assume that it's going to be U-shaped, so you would always find an efficient scale. So these cases, we're going to leave it for a more advanced course. Once you find the efficient scale, what do you do with it? That's how much each seller is going to produce. Now, assuming that you find the efficient after you find the efficient scale, you have to determine the price. Since the idea is that the sellers compete to offer the lowest price, the long run supply curve would always have the same price, and that price is going to equal to the lowest possible average total cost, as you can see here, right? The price is just going to be the lowest average total cost because of competition. If you don't charge at the lowest point, someone else would come in and say, well, I can undercut you and take away your business, so let me charge a lower price. This is the only point where this would not happen is the lowest average total cost. The supply curve is a horizontal line because we assume that there are many sellers. There can be as many sellers as necessary. Each seller produces at the efficient scale. Each seller produces the efficient scale. If the market has a higher demand, more sellers enter instead of each seller raising their output. So that's what's so special about this model. You're assuming that the market is going to adjust to the demand by having more sellers or fewer sellers. Each seller always produces at the efficient scale in the long run. That's the only way they can achieve the lowest price. So the total quantity supply is just going to be the number of sellers times efficient scale, and the number of sellers is something that we do not know yet because the number of sellers adjusts to demand. Higher demand means more sellers. Less demand means fewer sellers. So what's going to happen is, right, you have a diagram. We just argued that this is the long run supply. It's going to be fixed. Always going to be a single price, which is the lowest of average total cost. If there's more demand, more seller, less demand, less seller. So this is what's going to happen. With few, you're always looking at the same price, and you determine how much quantity demand is going, how much the quantity demand is going to be, and from there you can calculate how much each seller has to produce to fulfill this demand. How many sellers we need to fulfill this demand? So you just plug the price into the demand curve. You can solve for the number of sellers by dividing. The overall quantity supplied by the efficient scale. Okay. So that's how you do it. Price is, once again, long run price is always the same. Long run price is always the same. So the long run supply is a horizontal line. Number of sellers are, sorry, this is not Q1, Q2. This is number of sellers, sorry. This is number of sellers. Number of sellers. The number of sellers adjusts to the demand. More demand, more sellers. Less demand, fewer sellers. You can find the number of sellers by dividing the quantity the market wants with the efficient scale. What happens if you don't have, when your curve is not U-shaped? Well, when your curve is not U-shaped, as I said, you won't encounter this in this course. If the curve is not U-shaped, there are basically two possibilities. One, there's increasing average cost. So the more you produce, the more expensive it gets. What would happen in this market? You can actually apply the same logic. What happens is the sellers has to produce at the lowest cost. And in this particular example, the lowest cost would be at 0. Each seller produce 0. So you can, in some sense, you can say this is the efficient scale. The efficient scale is 0. If you produce almost, you can imagine that this is approximation, right? If you produce almost nothing, you would have a very low cost. So what would happen in this market? In this market, there will be infinite number of sellers, each producing tiny quantities. It's simply not worthwhile to scale up your operation because it gets too expensive. So everyone produce a little, and there will be many sellers. I can imagine what type of industry would be that. Usually labor, very individual specific type of service. For example, if you are, if you are tutoring, if you are a private tutor or a piano teacher, it's very difficult to scale up the operation of a private tutor or a piano teacher. Especially for piano teacher, you can't really teach a multiple number of students at the same time very well, right? Piano instruction is pretty much a one-on-one product, right? It's a one-on-one service. Very few piano lessons would occur with one teacher with many students. It's usually one-on-one. In an industry like that, one-on-one, you would have a lot of sellers. So there are a lot of piano teachers because piano teachers cannot teach more than one student at a time. Another possibility is you have decreasing average cost. So the more you produce, the cheaper it gets. This is a case where there is real benefit in becoming bigger. And you can see that the efficient scale could be in the infinity. The more you produce, the cheaper it gets. So when is your production cost the cheapest? Well, when you're producing infinitely many units. In this case, you would have a single seller dominating the market because the more he produced, the cheaper it gets. So how can anyone else compete with it? The single seller would be having the lowest possible cost, and no one else can compete. In that case, you really have to think about whether it's still a competitive market. It's kind of weird to say it's competitive when you only have one single seller. All right, so once again, let's look at the actual math of doing that. So I have this cost, it's the same cost function, same marginal cost function. Find the efficient scale and the individual and the corresponding average cost. So you want to find the efficient scale. This is how much each seller is producing. And you find that by setting marginal cost equals average cost. So 6 plus 10q equals to 20 over q plus 6 plus 5q. It looks like you're going to have a quadratic equation here. You're going to have a quadratic equation here, right? 10q squared. Right? So rearranging gives you q squared equals to 4. So it actually turns out very simple. Q equals to 2. So each seller is going to be selling 2 units. Right? That's what it is. Each seller is going to sell 2 units. The corresponding average cost is going to be, well, you can actually use average cost or use marginal cost because they intersect. It's up to you. Right? So let's just use average cost. 20 over 2 plus 6 plus 5/2, which would be 26. right? 26. As we mentioned just now, 26 will be the price in the long run. So no matter how much the demand is, 26 is the price. So the supply curve is going to be 26. Long run market price in equilibrium. So because efficient scale is 26, the long run supply, market supply, let me just say market supply. Long run market supply is just always $26. That's it. If you look at the diagram, it's the same as what I've shown you just now. Everyone has to produce at the lowest cost and charge the lowest possible price, which happens to be 26 in this case. No matter how supply long run. No matter how much demand there is, everyone has to produce at the lowest cost. If there's more demand, more sellers enter. The equilibrium quantity in the long run depends on demand. Now, that we have figured out the long run supply, it's time to add in the demand and find the equilibrium. So you find that by, looking at what would be how many units consumers want to buy at $26, which in this case happens to be at 100. Okay, so long run market supply is always horizontal. There are many sellers willing to participate in this market. So the higher the demand is, the more sellers there will be. So the final question is asking what each seller is producing. The market is producing 100 units, right? Each seller is producing just how many? Each seller is producing 2 units. So number of sellers would be 50. You need 50 sellers to fulfill all the demand. If the demand goes up, you would expect more sellers. When the demand goes down, you would expect fewer sellers. So the next part says, well, let's say demand goes up, right? Suppose demand goes up. And to make it a little bit more interesting, I assume that the marginal cost is actually going to be a bit higher in the long run if it's the short run marginal cost when deviating from a long run output is actually going to be a bit higher, just to make it a bit more complicated. So write down the short run marginal cost function in this case. So the idea is, well, if your short run output and the long run output is the same, then this term just goes away. But if you're producing more in the short run than the long run, then you have to pay a higher cost. So in this case, the long run output we know is going to be 2. So this is what the marginal cost is going to look like, which would be 12Q plus 2, right? Okay, we're going to use this function and find the short-run equilibrium again with when demand is higher. Suppose demand is higher, so now there's a sudden surge in demand. The seller wants to sell more, and then it's back in the short run. So what would happen? You just go through the whole process again. So you go through the whole process again. MC equals to 6 plus 10Q plus 2Q minus 2. And we already rearranged that to 12Q minus 2, right? So you replace MC with price because sellers are charging at the lowest possible price, which is marginal cost. Right, plus minus 4, that's, oh, plus 2, sorry, not minus 2, plus 2, because it's 6 minus 4, so it's plus 2. 6 minus 2 times negative 2, so 6 minus 4 is 2, 10 plus 2 is 12. Q equals to P minus 2 over 12. That's the short run individual supply. Market supply is, we have just now, how many sellers? We have 50 sellers, right? We have 50 sellers multiplied by individual supply. So there's really not much in, well, just, okay, whatever this is, right? 50 divided by 12, P minus 2. Market equilibrium is QD equals QS. You have 150 minus P equals to 50 divided by 12, P minus 2. So it's a matter of rearranging and punching the calculator. So you have something like, so you have multiplied 12 to the other side. So you have minus 12p, and you have 50p. So this is 62p. And on the other side, you have, what is it? 1,800 minus 1,800, so I think it's 1,900, I think, if you multiply, right? So let's see if this is correct. So price would be 1,900 divided by 62. Okay, so price equals to 30.64. So the price has gone up, right? Remember, the price used to be $26. Now it's higher because demand has gone up. Previously it's 100 minus 26 minus P. Now it's 150 minus P. So price has gone up. Price has gone up. So because there's more demand. Quantity obviously should go up because why would seller be charging more if they are not producing more? So the sellers are going to produce 150 minus P equals to 119.3 something, right? 6. Okay. So that's the idea. And if you draw a diagram, what's happening right now is, originally, you're at a long run supply. This is the original demand. Now the demand is higher. When demand is higher, I assume that there is a short run cost function. So short run marginal cost is actually upward sloping. So we are long run equilibrium is here, the black dot here. In the short run, the sellers cannot adjust as quickly. In particular, there is no additional sellers coming in. So that pushes the price up in order to induce the seller to sell more. Next, we could be going back to the long run. And in long run, there will be new sellers. So the price is going to go back down. In the long run, price is going to be 26, right? It's always going to be 26. As long as the average cost function has not changed, then it's going to be 26. Then quantity produced in this market is going to be 150 minus 26, which is 124. Efficient scale is 2, right? Efficient scale is 2. So each seller always, when each seller has to become the most efficient as possible, they all produce 2. So the number of sellers is going to be 124 minus 2, divided by 2, which is 62. So the number of sellers has gone up. Previously, we had 50 sellers. Now we have 62 because the demand is higher. The price goes back down. So once again, if I draw the diagram again, actually, there's nothing else I have to write. Okay, let me draw it downstairs so I can draw it bigger. Right, price, quantity. This is the long run supply. Demand 1, demand 2. This is the original equilibrium here in the long run. In the short run, the supply curve in the short run is upward sloping because you don't have new sellers coming in to drive down the price. So in the short run, the price would go up. Quantity also go up, right? Then, in the long run, new sellers would enter, driving the price down and producing even more. So if you're looking at a market, right, and you try to plot the quantity and the price over time, right, over time, what would you see? What would you see is, so let's say you have originally is very stable, and at some point there's a increase in demand. Now, in our case, because we are in a very theoretical model, right? We have a very theoretical model. So you have only 2 stages, short run and long run. But obviously, in reality, it would be a graduate process. So you would expect something like this, right? There's going to be slow adjustment. The quantity supply is going to go up slowly, and then until everyone is happy. For price in the same period of time, you would probably see something like this. You would see something like this, right? Price would go up very quickly for a short while, and then it go back down. Because when there's a sudden surge in demand, the existing sellers raise their price and produce more. But over the long run, you have more sellers entering and the price would gradually come back down. So whereas quantity would stay high, price would come back down and be stable in the long run. So this is what realistically would happen. You see, this is what you're going to see happening. All right, so we're not going to talk about what happens to a non-U-shaped one. As I said, you will not encounter it in this course, so you don't need to worry about those.